Hey everyone, welcome to Inventing a Free World with your host Matt McMahon. Today's show is with an inventor named Paul Babcock, and we'll be discussing secrets of magnets, magnetic secrets. I'm happy that we can share this with you. So I just wanted to say a big thanks to all the people that are involved in the show. That help out, and Kiki for doing the art, Marco for doing the websites, and the rest of the team. If you guys need any services, everybody's always looking for work, so you guys can check out our team on inventingafreeworld.com. We are presently on Dark City Radio right now, and you guys got to check out the other shows that they have on here. They're doing some amazing stuff. You guys got to listen up and hear what these people have to say. Natural cures, talking about environmental issues. There's a ton of stuff that is really open to the open source mind. So I'd like to welcome Paul Babcock. Hi, Paul. How are you doing, buddy?
Oh, doing great. Pleasure to be here.
Oh, it's a pleasure to have you. I'm very excited to have this show. So, Before we get started, I like to ask the other inventors, about the gifts that some of us share, and how does your gift of inventing work, and how far back do you remember it happening, and what happens? What are the triggers? Is it a device? Is it just a random thought? Is it just an image that enters your mind? How does your gift work? Besides the knowledge part.
Yeah, I guess it goes back to birth, the desire to just, I had this thing about electricity from as early as I can remember, 4, 5, 6 years old. And it turned into a hobby that turned into a career that led to really studying electrical physics very deeply. And then I just all of a sudden realized that how they were telling me the world worked and how electrical physics worked wasn't exactly how I was coming across it in the real world, and it just started me on a path of discovery, and I grew up in a family of inventors. My uncle invented farm machinery and just everybody, tools, electricity, so it was a great environment to grow up in, and it's just been a life's inspiration.
Awesome. That's and what about the I've asked a previous guest to the show. First of all, do you have visions? Do you see devices in your head? Does it work like that, or is it just?
Oh, absolutely. It's like I try to describe it to people, and a lot of inventors out there have said the same thing. Is they literally have a world in their mind, a laboratory in their mind, and when I go into the laboratory of my mind, I do experimenting, and it's just the vision. Sometimes it's with dreams, sometimes you'll just be sitting there in a chair doing something innocuous, and it's like getting hit by a brick. All of a sudden, side pops into your head, and then spiritus takes over, and you just can't let it go, and you pursue it till you figure it out.
Yeah, I call it a beam of light. As we've discussed, my theory is that most humans are sort of interconnected, and we can connect through sort of paths of light, because most people know that human bodies are magnetic, and light is a type of magnetism, as I believe from what I've looked into. You may want to correct me on that, and I would more than.
I call it the biological internet.
Okay, yeah, and as we've both discussed, that we sort of we both have the ability and belief that we can connect with other minds around the world on same or similar ideas, or random ideas for that matter.
It's absolutely true, and it's also a timeless thing. Every generation has the same thing. There's just people who are here to bring this information to a generation, and that's their job. That's why they're here, and they have that special talent, and I don't really focus on it a whole lot. I just let it work in its natural form, and it works great for me.
Yeah. Yeah. That's. So did you notice that it happened more when you actually started teaching yourself about different technologies, or was it has it always just been the same?
It comes when it's supposed to. It's like I'll spend sometimes a year or two in the lab, just trying to work out ideas and whatnot, and then all of a sudden a question will drop into my mind and a whole new offshoot takes place.
Yeah.
Or I'll be reading somebody else's work and I'll see a simple sentence or a statement, and then all of a sudden, pow, it just flows into your mind, flows into your being. You start to vibrate. As Tesla described it, to paraphrase, the inventor's rush, is better than sex.
Yeah. The orgasmic epiphany.
Exactly. And man, once you get it, you're hooked for life. There's just nothing quite like it.
Yeah, it's a drug that you keep trying to keep finding it. You actually really nailed it there by saying that. Sorry, I'm just trying to cover for my work right now, for my second job. You had said that when you look at another device or you read something and then boom, you get it. No, it's the question. I often find that if I look at something, I go, the thing that triggers mine most is what if? What if it was like this? What if it was like that? And then my brain takes over and sees all these visualizations and sort of starts going nuts. So how about we get to your motor? That's quite an interesting piece of equipment. Could you try to verbally explain it in a visual sense?
Oh yeah, absolutely. It's maybe a little bit of the pre-work on the physics and how we came across the physics is, my brother and I we've been chasing electrons together since we were kids, and I wound up. I spent many years in Alaska, and we all worked in the big electrical industries. We started out as just basic technicians and taught ourselves engineering, and pretty soon we were top troubleshooters for big corporations around the world, and we were the guys that dealt with the electrical physics. And all of us, my business partner, my brother and I, we just had this, we just knew that there was something missing in the theory, because we'd see these energy phenomena when we're playing with big DC power systems and whatnot. And of course, we're all Tesla fans and read all the stuff, and we just were trying to pin it down. What was going on? Where was the theory? I mean, it was just incredible, some of the phenomena we'd see that nobody could explain, and of course we're dealing with big companies and whatnot. They just sweep it under the rug, but we'd find the solutions to problems, and we all made really good livings at it. And then how the real inspiration started was when I was in Alaska and I was having kind of a rough year, and I got hurt in an accident, and I was out of work, and so I was living in this little cabin in the woods, and just getting by, and arm in a sling and a cast, and it's about 50 below zero, and chopping wood with one arm, and all I had was a little AM radio, and we had this local radio announcer who announced that his guest that night was going to be Joseph Newman. And so
the Newman motor guy.
The Newman motor guy, and that was in like 1988. So
okay.
I said, well, being an electron chaser, and I said, man, this sounds great. I just got to hear what this guy has to say. And so he totally captured my, he was saying, I got what he was talking about, while the guests, while the audience was giving him a hard time, calling him a quack and a moron, because they couldn't believe that, over unity was a possibility. So I scraped, and he just said, well, buy my book and read the book and then criticize me. So I went and I scraped up the $50 and bought his book. And when it got to my door, I opened the pages, and there was this is one of those epiphany moments. There was a simple statement he made, and it was just absolute brilliance. And from that moment on, I jumped down the rabbit hole and never looked back.
What was that statement, Paul?
It was that the amount of energy you expend to make a magnetic field has absolutely, the amount of energy you expend to create a magnetic field has nothing to do with the amount of magnetism you make. In other words, what he was saying is by controlling the mass in the circuit, you can create a whole bunch of magnetic flux for a little bit of energy, or you can spend a lot of energy to make a little bit of magnetic flux. So there was absolutely no direct relationship between those two. And it was like getting hit upside the head with a frying pan. The implications for that. You know, being a serious electronics guy, I understood that, wow, if I can make a very large magnetic field because of Faraday's law, and I don't expend very much energy to make that field, I should actually be able to get more energy back out of the magnetic field than I used to make it. And so then I started working, and then and it was just from that moment on, that epiphany was, like I say, that's when I jumped down the rabbit hole and I've never looked back. And that began a lifetime, 30 years of serious research and development, and to develop the electronic systems it took to exploit his theory. So I studied his theory very thoroughly, and I studied everybody. And then after the studying got done, I says, okay, now it's time to go to the lab. And so that's what I've been doing for over 20 years, developing the control systems in a way and a whole new level of electromagnetic control and manipulation. And we've done some amazing things with it. So that motor you see is basically a Newman-inspired system. And so that all that came out of that one epiphany, that one moment.
That's usually what happens to all of us that sort of make us want to pursue an alternative. It just took one person's technology to just get you wanting to learn more about it and wanting to explore that. And then when you do that, you tend to expand into other things like, as you did with Tesla and, all these other amazing inventors that have never really had a chance to have the future that they saw come to life. And it's very unfortunate.
And that's how it works through history, is we always stand on somebody else's shoulder, and then somebody will stand on our shoulder as society progresses. And so, to have all these great inventors and great minds, I mean, they be inspired and point out very basic things led to my own inspirations, And so one of the things the first thing we started to do was, how do we, Tesla, Newman, how do we relate it to the known laws of physics we already know? Ohm's, Kirchhoff, Faraday, all these basic electrical laws of physics that we live by and have created a civilization by. I says, this has to relate. So what we did was we basically proved that OU is a total fact, and our known laws of physics, Ohm's law, Faraday's law especially, say it. It's just staring you right in the face. And so that's what my videos that you watched are about. That's what when I do lectures, that's what I speak about, is it's already there. We already know how to do it. It's, if you know how to run the simple algebraic proofs, it's just a fact that electromagnetism, or magnetism specifically, is an energy form unto itself.
Yes. I wanted to mention something in regards to all these people that sort of made physics what it is today. They were also inventors, and they found a way to apply their understanding so other people could understand it in, mathematical terms. Now, it doesn't mean that they had the opportunity to test everything. They only had, especially due to the fact that most of the physics books were written over 100 years ago, that their understanding of even what we can presently do today is nothing in comparison. And there are laws that are within physics, but there are definitely a lot of holes that need to be filled in because of the fact that it was so, their technology's outdated now. They didn't have microprocessors and even to high switching and things like that. So
absolutely, it's like Nikola Tesla and Faraday and these guys. Basically they had lumps of metal and wood And, that's all, and a little brass and some screws, and that's all they had to work with, and they literally explored electricity in depth with virtually nothing. I mean, their mind power just boggles me to this day, their intuitive powers, and how they could create all this stuff like Tesla's creation with what he had to work with, what he created. I mean, what, I don't look
visionary.
At Tesla. Not just a visionary, but a prophet,
Yeah, well, that I think that's sort of one and the same, is it not?
Yeah, and just, and to me, we got robbed of about 100 years of progress by the powers to be. I mean, we're literally back in the day when Heaviside and all these guys were developing the laws of induction and whatnot. They pretty much warped a lot of the real math that was coming out of it to just create a standardized system. Maxwell, Heaviside, not that they weren't genuine guys, but so much of what was possible was pounded into a simple mold that basically said, that stuck to, tried to fit electricity into the law of thermodynamics, and it put it in a box. And the box led to the system we have today. Well, now, and Tesla said, well, you've robbed this century of what I can do, but the next century is mine. And I think that's where we're at right now, is all this theory is coming out of the box that was hidden from us.
Yep.
And that knowledge is spreading rapidly.
Yeah, many people can feel the change happening, like not only feel it physically, but, you just look at all the inventors that are really putting themselves out there that are, not so, they just want to use the ideas that come to their head as methods for other people to learn. And, could you get into a little bit more about your motor? I'd really like people to share. And actually, before we do that, the videos that I saw, I definitely suggest anybody to go and purchase these videos. They're more than worth watching them. So if you want to know how free energy works, Paul's going to explain it to you, and he's going to give you math, especially if you are a physics buff and you think all this stuff is a bunch of hooey. I was absolutely blown away by watching these videos. So you guys got to go and see what he has to offer in regards to knowledge. So where can people find that video?
A&P Publishing, Aaron and Peter Lindemann's video publishing company, which the name of it escapes me right. A&P Publishing, I believe, is the name of it. But you can find it on energeticforum.com. Any of Peter Lindemann, John Bedini's site. They sell all kinds of, and all the videos. They publish a lot of inventors' videos, and they're all good. Peter Lindermann's videos are outstanding. Jim Murray is another great inventor that's a really good friend of mine. He has a laboratory full of stuff that will blow you away. And so all those videos they're publishing are well worth, and for the price you pay for them, it's just incredible information.
Yeah, they're sort of priceless.
Yes, they are. It's the best investment you can make, and
we'll
be publishing more of them.
Well, I would like for you, if you ever need a place to share any of your information, and we will try to get that link for your videos put in. We sort of made a profile for all the inventors now, so that way anything that we're going to be discussing will be put, when you make reference to names, we'll try to get some links to go with it. But it takes a lot of work, and we're trying to get everything going. And if anybody wants to get involved and help us with this, we need some people to help, because there's not enough people to get all of this information. So other people, when they come to our website, they can just easily find it. And if you're listening to this in the future when it's a recorded show, all you got to do is go to go to our website, inventingafreeworld.com, and go to Paul Babcock. And we'll have all the names that he's listed and all the information. So if you want to be a part of helping that, inventing a free world, that would be awesome. So, so your motor, I remember a lot from the video that you described about it, but I would like you to describe it.
Well, it's pretty much, it's a Newman, it's,
but not everybody knows what the Newman motor is, so.
It's, Joseph Newman, his theory, right? You have a gyroscopic particle theory, and it's all based, that's the original inspiration. But what it's about using the known laws of physics we have. With electricity, Mother Nature is not stupid. Mother Nature's system there's nothing more abundant than energy. But energy is designed to be balanced, because otherwise the universe would blow up. So in electrical physics, Mother Nature built in governors to keep energy runaways from happening. It's all designed to be a balanced system. So in reality, once you understand these laws of balance, there's two of them that are actually the governors that are built in the system to make sure you never really go into an over-unity state in nature. And there's reasons for that, why Mother Nature did that. But in electricity, one of them is electrical resistance, and the other one is called Lenz's law, which is basically what science would call the conservation of energy law. That if you take a magnetic flux and you generate an electrical current with it, that current makes an equal and opposite magnetic field and produces an oppositional force. So in order to convert more electricity to torque or motion, you have to actually expend more energy to get it. So the whole concept of what we did is so that's one aspect of it. The other aspect is making electricity work multiple times. We found that just because you make torque and motion with electricity doesn't mean you've necessarily lost the original electrical charge that you used to create it. So what we do is we use several aspects. One of them is we learned how to beat Lenz's law in countermotive induction by coupling in space rather than inside the magnetic bodies. So
now, don't mean to cut you off, Paul, but you are using a lot of very technical terms. So
yeah, I'm trying to tame that down. So basically, what we did is if I boil it down, is one, we eliminated countermotive drag, which means you get a magnetic drag in all motors. That in all standardized, like Tesla type based motors, you get a drag force that you must expend electricity to overcome. And so if you want to make more power, you have to expend power, which means in the perfect world that no matter what you do with that type of design, you have to spend 746 watts to get a horsepower. And so there's your electrical consumption. But by reducing the drag force, by eliminating by coupling in space rather than within the magnetic bodies, we learned how to reduce that number to where you can actually spend, and many a scientist has spit at me over this because they think we're beating the laws of thermodynamics, which is absolutely not the case. But we can actually expend far less energy to get a horsepower of energy. And then the other thing we do is once we make a magnetic field to drive and create motion and force, then we recycle most of that electricity and get it back and recycle it back and even get a further reduction of energy consumption.
So you're just not wasting the energy like how all the other systems are. You're trying to capture it before it escapes.
Yeah, and what we're doing is we're tricking Mother Nature's governors. We created architectures that actually eliminate Mother Nature's control system, and so it works very well. Our prototype there, once we got the math out of it, and we built it. Building it was one thing, making it work was another. It took us about 2 years to build it and test it, and it's the very first one. It's the very first prototype. It's one of a kind in the world. And when we get a chance, we're going to go off and build the next one. But once we built that motor, we thought the world was going to greet us with open arms, and we went out into the industrial world, and we basically got beat with a club. And, and so we pulled back a little bit. That's
nothing new.
Yeah, exactly. So we basically pulled back a little bit and decided to take the electronics technology that we developed to make that thing work and start applying it to more standard applications to create a company where we had really good products that weren't quite so radical, to get our company off the ground and profitable so we could further all our other research. And so that's been a long haul, but that's what we've done. And so now we're sitting on a wide variety of technology. And the motor, we can't wait to get back to that, but it's actually been on the back burner for a while just because of how we had to deal with the world.
Now, Paul, we've had a bit of this discussion, but so many people want to just do stuff. They want to see how it works. They want to understand how it interacts. Is there any way that you could, say, make a very miniaturized prototype of that very large motor, so that way people can just see what's going on?
Oh, absolutely. And what amazes me, and I know other inventors who, just because of the dream world inspiration, have created very similar things to our motor. But the theory, we all have exactly the same theory. And we understand that if you counter Lenz's law, which is the law of counter-motive induction, that you just radically alter, and what it boils down to is that magnetic lines of force are, if they're not energy, they impart energy. And that's the deal is what you're really doing in reality is you convert magnetism directly to force and torque and electrical energy. So, and it's pretty complex, and there's a lot of aspects to it. And I don't know quite how to totally go into it without getting too technical on people, but it all boils down to the theory that magnetism is more magnetism, and that's why I really like to go to the gyroscopic particle theories, is that electrostatic lines of force and magnetic lines of force are an energy unto themselves, which is totally anathema to standard physics. They say they consist of nothing, and that just is not the case. There's a real gyroscopic aspect. They have aspects to it where you have continual motion and force within magnetism that you're really turning to force and electricity if you know what you're doing. And that, once again, gets down to tricking Mother Nature's governors, resistance and Lenz's law. And it's all right into the basic mathematical formulas we already know. So that's the whole theory behind the motor, and we proved it beyond any shadow of a doubt that it works. We got a lot of empirical data on it, and the next one we build is going to be a real game changer.
So with the motor that you did, I remember in the video you said something like, let's just round some numbers just to make it easier, but you said that, say horsepower is 700 watts instead of, I think you said 736 possibly. Sorry, watts per horsepower.
And that's the standard figure that comes out of Maxwell's equations, which are the equations that are always used to design motors.
So how much energy does your motor require to create a horsepower?
This particular one, we actually built limitations into it purposely because the magnetic fields we were using were so powerful, we were burning up our electronics. So we actually built some limitations into it to get our benchmarks. And the real thing we're trying to do is to just prove that we could make it spin. But once we got the math and we derived the math, we look at it as we should easily be able to get, a horsepower for every 150 to 200 watts of electrical expenditure. So
that's a third of the power almost.
And that's why. Third or less. And why that happens is we're actually translating magnetism to energy, which, I get beat with a club when I say that. When I'm dealing with my own company and I'm dealing with the patent office and other places, you can't make me say it. because it just, but so I kind of live in two different worlds. We have two different sets of physics that we explain things with. I can use standard physics that nobody argues with to advance the company cause. And then the real physics is it's just a blatant fact. And it's, argue with it all you want, but magnetism is a form of energy that can be exploited. And that's what really happens in all these things. Anytime you have somebody that's doing these magnetic things that create more horsepower for 746 watts, or they get more than 746 watts out of a horsepower of energy input, mechanical energy input, it's a translation of magnetism directly to electrical energy or torque and horsepower. And it's built right into the laws of physics. They're staring us right in the face. It's just not that difficult to understand.
Well, for most people.
Yeah. Well, not everybody, but for people who deal in engineering and whatnot and study the laws of physics, you just have to rise above some of the assumptions that are out there.
Yeah. So with your motor, you said you built in, I forget what the word was that you used, but you made it so it wouldn't. Pardon me? So
the dang coils wouldn't blow up our switching devices. We were generating such incredible energy out of it so we purposely built some limitations into it. And like I said, it was the first one. But we got
So you built these limitations into it as probably how I sort of invent things. I'm sort of assuming that you did it this way, so that way you could get your variables down.
Exactly.
Yeah. Exactly. So then when you have your variables down, then you understand the nature of the device.
Exactly. And that's what it was built to collect empirical data. And we got lots of data off. And once we could interpret the data, we just knew we had it. And we still know we have it. And then lots and lots of technology has come out of that motor since then. And so we've really advanced it comes down to the electronics. We had the theory clear back in the 80s, but it took a while for the transistor technology and the microcontrol technology. I mean, the electronics to make it work are pretty sophisticated, and we had to wait till we had power switching devices and a lot of things finally caught up in the mid-90s to make it practical. And so when technology caught up with our electronics needs, that's when we really got rolling on it. And so now we've really spent quite a few $1 million and not a whole bunch of millions of dollars, but plenty of money. And we hired an engineering team and we put a good staff together, and we've turned our electronics to very sophisticated, very powerful electronics. And that's our platform for taking these new technologies we developed to the next level. And so we also have lots of great products that we're taking to the market out of that research. So
do you have anything that's on the market right now? And if so, or if not, what website can people find what you're up to?
Yeah, if you go to our first product is a inductive lighting controller we built for industry, and it's we can took up 10,000 watts of inductive lighting, HIDs of all types, high pressure sodiums. And what it does is we actually extract what we call magnetic energy recovery. That's the specialty of our company, and that's what our electronics does, is we recover wasted magnetic energy out of these devices and recirculate it back to the load, so it runs the efficiency up the devices. Then it's also a full dimming system, so we can cut 50% of the power consumption out of these lights. Lighting is a huge load on the grid, and so we can reduce energy consumption by 50% with this type of lights.
So then instead of using 10 kilowatts, they're using 5 kilowatts.
Correct. And so and it also runs off you can run them off DC power and AC power and integrate it with alternative energy sources like solar panels and wind generators. And radically and radically reduce your energy consumption from the grid. And it's a universal device that we use for a lot of other things. We've created what we call our mini microgrid system, where we can go to pretty much any poor place that has no power and put in a miniaturized grid system that's all alternative energy based before you use fossil fuel. We've got high efficiency generators that are like ethanol based, so communities can create their own fuel and operate and literally create their own grid system and supply their own power without having to be tied to the hydro dams and the coal plants. So,
it's the nuclear power plants that worry me the most, but these countries probably don't have them.
Well, it's a simple fact that half the world actually doesn't have any electricity. So
no.
And so
we actually have a guy that's listening that's in from Trinidad, and I believe it was him, but they get brownouts all the time. So, their power isn't always at full tilt.
Yeah, we're actually dealing with some companies out of Trinidad right now, and see, that's what our mini microgrid system is designed to do. And it's all based on our electronics and our technology, to where we can take alternative energy and convert it to beautiful, high quality utility power that can be transmitted. So we can go into a little African village and we can power them up off, and everything integrates together on the power lines. And so you use multiple sources of fuel. You use whatever resources you have. We have mini hydro systems, mini wind generator systems, solar systems, and it converts it to beautiful power, incredible efficiencies, and then transmits it where you need to go. And so
where can people find this stuff? Do you have a website that people can find this at?
Actually, we have our website, www.flybackenergy.com, and a lot of it's on there. And what's in our R&D department that hasn't been converted, we don't put our R&D on our website. And that's just because, your competition's glad to steal your R&D and run off with it. But yeah, there's a lot of this stuff you can find right on our website, our lighting controller, some of our mini microgrid stuff. And we had a little bit of a rough year, but we're back on board, and we're marketing. We're just starting heavily into our marketing. We had to get all the UL approvals and everything on our equipment. So when you're commercializing product, it's quite an adventure, very expensive adventure. Having it in your lab is one thing, and proving the principle, but then commercializing it and taking it to the marketplace, that's a whole other thing. And
you're better off becoming the marketplace.
Yeah, well, there you go. But we kind of did the standard paradigm when we started the company. We have stockholders we're responsible to and whatnot. So when you get out there in the world and you take people's money, they expect you to make some money. So that's kind of the dichotomy of the thing is you have responsibility to all these people whose money you took. So we have a responsibility to go out and market products and make our stockholders some bucks, which is not a bad thing, because we're taking great technology out there that's going to make a better world too. So it's kind of the best of all worlds if you're doing it right.
Well, it's awesome stuff. I'm definitely going to check your stuff out after the show. I guess I should have probably prior to the show, but
yeah, we've had problems with our website here for the last month or two. It keeps getting taken down for some reason, kind of like Aaron's had his problems, but we keep putting it back up, and it's there. And we're just, like I say, we're just heading out into the big world of marketing, and we're excited about it. We're a little behind, but things happen, And,
it can only happen in time.
Yeah, it's
so normally what we do is 45 minutes after we get into the show, we ask for callers if they have any questions to call in. Are you okay with that?
Oh, I'm totally fine with that.
Okay, so to anybody who is still on the website right now listening to the show, you can push, but make sure to press mute. You can press on that blue Skype button underneath the live stream, and you can come in and then put a number beside your name in order of who has last put their number. So if anybody would like to ask any questions, please please put your number down, and we can bring you back in, or bring you in to begin with. And maybe we should play some Jeopardy music while we do that. Well, there was one, Andrew. You were saying a lot of stuff. Did you have any questions? Well, looks like, we got Frank for one. Go ahead, Frank.
Hey, Paul, how you doing?
Great.
All right. I've actually followed a little bit of your technology through a number of things, and what interests me most is the breaking of the Faraday law and all that stuff. Can you get in a little more detail in how you do the conversion of making sure it doesn't give you feedback, so to speak?
Yeah, it's what we call space coupling. If you look at a regular motor, you really have two magnetic bodies that are tightly coupled, where one's magnetic flux has been pushed right into the magnetic core of the stator, and it's just the opposite. So you have two completely clashing magnetic fields. And so that's what creates the drag force. So what we did is we figured out a way to where we couple in space to where outside of the coils, and we still get plenty of torque and horsepower, plenty of drive force, but to where the flux from one body doesn't cut into the other magnetic body. And it's quite a trick. So it took timing and sequencing of coils, and that's why we used what we call a segmented toroid, to where whatever coils the armature is spaced over, that coil is off and can't induce any current through it. And as long as you don't induce current into your coil, and so the outside two coils are really creating the force outside the magnetic bodies in space. And so that way we don't get one flux from one body cutting into the wires of the other body. So the armature is actually permanent magnets, and they're being forced by the electromagnets, but all the coupling happens outside the windings. So that's how we beat Lenz's law and counter-motive induction. And it works quite well, but it's fairly complicated electrically, and it takes some real precise timing with digital timing and whatnot to make it work. So it wasn't an easy task to pull it off, but once we figured it out, it really does work great. It's not easy to beat Mother Nature, but we did it. And it's just one way of several ways of doing it.
Cool. That sounds like it's, you're right, pretty complicated, just getting it just right. Yeah, I was looking into a lot of that in a toroid type of coil and doing something similar.
Yeah, it's toroids are really the key. And I tell you, we must have burned up. I mean, we called transistors just dead soldiers. I mean, we burn up to get it to work. We burn up over 1,000 transistors before we got it right. And the other part of it is what we call flyback energy. Hence the name of our company. Is like the other aspect to it is once we figured out how to reduce the effects of Lenz's law, we also wanted to use magnetic energy recovery, because we figured out this process to where we can create stronger magnetic fields and have more wire, because we beat what's called impedance. We get what we call reduced impedance effect. So we're able to run high frequency current into very big coils that would normally reject those frequencies. And we call it zero stating the inductor, zero stating the coil. So we extract we build up a magnetic field with a high frequency pulse, and then we extract all the energy back out and then recycle that energy. And all kinds of real positive electrical effects came out of it. So what it really allowed us to do was to create force and torque with electricity and recover that same electricity back, or most of it, and then recycle it right back into the system. And that radically dropped our power consumption. So electricity can be used twice and 3 times before it gets away from you, which is the other aspect of this motor. So there's a whole bunch of stuff going on that we do, and it allowed us to create very precise control of the magnetic field strength that we use. And like I said, it's a pretty complicated device, and it took us 18 months to build it. I mean, building it was one thing, making it work was the other. And we had to create a whole digital platform and control platform, and eventually we got it down, and now we're ready to build the second one. Like I say, I think it was about 10 years ago we actually built the thing, and so we actually had to put it on the back burner. So it's one of my passions is to get back and building the second one, and the second one's going to way outdo the first one.
Yeah, that's cool. I guess you just keep improving.
That's how it always works. The first 4-cycle engine wasn't much to brag about either, but look where they've gone.
Yeah. Could you describe, because I know that we got a few tinkers on listening in on the show, or that will in the future. Could you describe what you use for core material? Because I know that's going to boggle everyone's mind, and they're going to love it because of the way how it's so cheap.
Yeah, well, that was the deal. When you're making electromagnetic devices, you got to have the materials, and one of the materials you need is good electrical steel. And because if you don't have the good electrical steel, you get all kinds of losses that happen in heating in your core materials. And so how it's done now is they have what they call silicon steel, it's low carbon, and they put silicone in it to make it highly resistive. And the enemy is what's called eddy currents. When you get magnetic flux running through chunks of iron, you get current flow within the iron, and you get inductive heating. It's the same thing as the inductive heater on your frying pan or an induction furnace for melted metals. You get all your electricity goes to heat, and you lose so much energy. And so how you do that is you have to have a low carbon or zero carbon steel, because the other problem is because if it holds any kind of magnetic flux, if it becomes magnetized, the harder the steel, the more carbon in it, the easier it gets magnetized. And then you constantly have to overcome that magnetization. And that even eats up more power. So if you got a bad core material, you lose all your power, and all you do is get something that's very hot and no performance. But for an inventor to go get high quality electrical steel, that means you have to get the plate stamped out and laminated, and you have to go to the manufacturer to do that for you, and it just runs and broke. And every time you need a custom core made, they're nicking you for thousands of dollars. And so when we went to build this motor, we had a bunch of funding lined up to do that, and that was right in 2001. And when the airplanes hit the building, for some reason, our investors decided they were scared to death of the world, and they pulled all our funding. And so we were left with, we had to fall back on a simpler, better way to build our motor. It was killing us. We couldn't figure out a way to create the core materials we needed without going broke. We just didn't have the budget for it all of a sudden. So, lo and behold, one of those inspirational bricks in the head thing again, it dawned on me that
Dark City is yours.
When they forced the world to go to steel shotgun pellets, they had to make the steel as soft as possible, and they had to take all the carbon out of it. And it was also when you could buy it in pellets, so it was the perfect, really high quality core material in a shotgun pellet. So we started buying number 7 shotgun pellets, soft steel shotgun pellets, or zero carbon steel, and then we would coat them with an acrylic layer to interrupt any conductivity between the pellets. And then all of a sudden we found we could pour and mold. It's beautiful. We could make a mold and mix it with epoxy and pour it into these molds. I mean, literally for a couple of dollars, we had a great core. And so for experimenters, it's a great way to build your devices. Anytime you're dealing with electromagnetics and you're building cores and motors and stuff, you can literally pour and mold this for, for $1 a pound or whatever, and save yourself thousands of dollars, and get great devices and great performance.
So do you think that this would work with a Bedini motor?
Oh, I've got one in my shop. Yeah, we built a couple of them. It works great with the Bedini motor. Absolutely.
Awesome. And did you notice any variable differences by doing that?
Oh, it makes your coils run much better. We did some comparison. Generally, with the Bedini motors, people take welding rod and they slide the welding rod into the core, and the welding rod gets magnetized, and there's a lot of loss in it. But if you use the pellets, all your loss goes away, and it performs much better.
So do you think that you can actually, like I've made a Bedini motor, and I know Frank has, and we consume 12 volts at 250 to 300 amps. Milliamps, depending on the magnets we use. So would that consume less, or would you get more RPM out of it in turn?
You definitely get more RPM, because what happens is all that loss, some of your electricity that you're running into the thing is actually converting to heat in the core. Well, instead of, if you have the good core material, it doesn't convert to heat, and you get much higher, and so you get more magnetic field out there to push against the magnets, and you get much better performance.
Awesome. Do you think it'd create a little bit more torque?
Oh, it most definitely does, and more speed too.
So that might be definitely something worth experimenting with.
Oh yeah, absolutely. It's easy. I should send you some pictures. I do have some pictures of that. I've got one. I had a little time last winter, so I was helping some people who were really getting into the field, experimenters. So we went into the shop, my personal shop, and we built 3 of them. And we used all the pellet cores. It was easy to do. We just took a plastic tube and made a coil form out of it, and poured it full of pellets and some epoxy, and then wound them, and they worked outstanding. Very, very highly efficient. And,
awesome. So when you put the ball bearings in, like you pre-coat them with an acrylic spray, do you just let them fall wherever they want, or do you try to strategically place them?
Oh, it's like pouring water. They just fill in.
Okay.
And the place I buy them from is called Precision Reloading, and you can find them on the internet. Just type in Precision Reloading in any search engine, and go to the soft steel shop and buy the numbers. So you can buy them from double-aught buck to the number 7s, which is the tiniest. Time smaller the better, and they have a very thin zinc layer on them to prevent rust, and the zinc makes no difference to the performance at all. And so you just lay them out into like a flat cardboard box, some cheap Home Depot, quick dry acrylic spray, just one coat on them, let them dry, and then that breaks up any conductivity between the pellets, and that's what keeps your heavy from generating. And then you just pour them into a mold and you don't even have to really mix them with epoxy or anything. You want to cap the ends, but so we pour them in a coil form. You pour a little, and set the one end of the open coil form down on a piece of wax paper on a flat surface. Drop a little fresh epoxy in, pour some pellets in, a few drops of epoxy, some more pellets, and when it's filled to the top, that epoxy sets and dries, and you got a beautiful core. And it works great. And then you wind the wire on it, and away you go.
Awesome. So is it precision reloading or preloading?
Precision reloading.
Okay. Awesome. So, just out of curiosity, how come, or maybe you have you tried melting these down to sort of make your own, solid cores, or do you, from the experiments that you've done?
It's very important to have them in the small, that's why they laminate cores. They take like 16th inch sheet metal, and then they stamp them out, and then they stack them up together with they coat it with an epoxy paint, and then they stack them together and then bake them together, and that interrupts the electrical conductivity between the plates. And that's the whole idea, is to have lots of iron there, but to have them small pieces of iron so that you don't get long conductive bodies that can really create long loops of eddy current. And then when that eddy current gets to flowing around in your core, that's what heats the core. It's just like an inductive stove top. You stick a frying pan on it, and it's actually a magnetic field that's collapsing up and down, and it gets eddy currents running around in your frying pan, and it turns it hot enough to fry eggs. So that's what you don't want when you're trying to do electromagnetic experimentation.
Yeah, you're in the video you had mentioned when you showed a physicist or someone along those lines, and you told them to touch it. Can you tell us about that story?
Well, and that's what we do with our in our technology. We drive transformers, so we created an inverter, and an inverter converts DC energy to AC energy. And so out of our technology, we patented a new transformer design, and it works on the same principle. We extract what would normally be magnetic energy losses out of the transformer. So we make, by being able to use our technology, what we do is we have a high-speed switching system that when we get a magnetic field built up in that iron, we turn right around and capture it back and turn it back to usable electrical energy. Now, the physicists would tell you that that's impossible, that the what's called the hysteresis losses are inherent to the material, and that's not true. We've proven it time and time again. So when we're actually running our transformers, everybody out there in the world that knows that when transformers are operating and under load, they get very hot, and you just don't stick your hand on them. Well, when we run our system, the transformers stay dead cold. They hardly heat up at all because we've eliminated that hysteresis loss. And so when it's running, and I've had many a physicist and engineer, they look at our system, and we run typically better than 97% efficient, pretty close, and the transformer runs better than 99% efficient. And they see that transformer there running all that power, it should be hot. Well, you can put your hand right on it, set your coffee on it, and it won't keep your coffee warm. And so many physicists and engineer has touched the transformer, and they won't do it because they think they're going to get burnt. And then when they do touch it, they don't get burnt. You just see the blank expression happen, and then they start looking for wires, and how are we fooling them? Because it's so ingrained into the thinking that when you have transformers, you have inherent losses, and that's not true with how we do things. So we exploit magnetism, we get that energy back, and we reuse it. And that's how we're able to do such extreme efficiencies. We do the same thing with our lighting controller and inductive lighting. The transformers are up there, they just get smoking hot because of the losses. Well, we take that loss completely out of it, and then they run very cold. And it makes them last longer, and we get all that energy back, and it cuts your light bill just recovering the lost energy. So
you're building transformers out of these shotgun pellets then?
Well, we do. When we have our commercial stuff, we just have it manufactured. But yes, we build all kinds of transformers out of the pellets. They work great. I mean, if you want to make a transformer, you can make an incredibly efficient transformer. It's like what we'll do is we'll take a core, and we'll write, and you can do the transformer math to figure out your winding ratios, and you wind one set of your primary on, and then you wind your secondary on, and then you set it and then you just put it in a mold, and then you surround all the wire clear up over the top with pellets. So it basically makes the whole thing right around the windings and everything. And then you wind up getting a very beautiful transformer out of it, So it's like if you see a transformer, they have what's called an H core,
I know that one.
Yeah. So it's basically an H core thing, except it completely surrounds everything. So you can actually mold an H core if you want, and do the windings and bolt it together. But you can build transform anything you want. You can build with these pellets, and it'll work great for you.
Well, that's that's pretty cool. Do you do stuff with non-magnetic cores? Do you dabble in that stuff too?
Yeah, a little bit, not as much as we'd like to, because all our time and energy gets focused on where we're at right now, because it's like a work farm, and so we've got a laboratory full of stuff, and we actually went the other direction. The whole electronics world went to high frequencies, where they're higher and higher frequencies to do what they want, where they have air cores.
And the core materials can't handle that high frequency.
Yeah, real exotic core materials to go to the high frequencies, and that has its advantages for certain things. It's a great technology to do for like small power supplies, and it's like your computer. If you had to have an iron transformer in your computer, you couldn't afford it. So that technology has been used for like computer power supplies and your TV, and it's great. It has its place. But we went the other direction with low frequency. So we went right back to 50 and 60 cycle in the big iron, because that's where the big power is at, and applied our technology there. And we came up with tremendous advantages over the high frequency technology. So what we do is...
That's really amusing, because most experimenters know that 60 hertz isn't great for resonance.
Yeah, well, and that's one of our deals is what we don't do resonance with. With our energy extraction technology we use, we pretty much make resonance go away. It's what we call zero stating the inductor. So every half cycle, we extract that energy back out and return that inductor to a zero state of energy before we go the other direction and re-energize it. And what we do is we get what's called reduced impedance effects. So all of a sudden we eliminate the bucking forces, because when you put energy into a transformer, Mother Nature instantly turns it around and creates a bucking force with it to govern you and make it so you have to expend energy to get more energy to go into it. So by zero stating the inductor every half cycle, we eliminated that problem, and it allowed us to do amazing things with low frequency electromagnetics. And so we have a whole portfolio of technology we've based on it. And we take our lighting controller, we can use it, we can drive motors. We do the same thing with motors, transformers, lighting systems, inverter transformers. Everything we stick it to, we recover that magnetic energy, get the reduced impedance effect, and we radically improve the electrical efficiency of all the devices we drive. So that's where our commercial focus has been. And all the other stuff so that's why we have a separation of two worlds: our commercial focus for our stockholders, and then our true love, which is really pushing the theory and turning magnetism into energy. So it's a little bit of a balancing act that we have to do.
So with this next plan for the motor prototype, what are you expecting to get out of that, and where do you see this motor going in the future? Like, do you see it driving cars, or do you see it just generating electricity? How do you see the future of this?
Probably beat me with the club for speaking about this too much in public, but it's really simple. If you turn magnetism to drive and torque, and you're only spending a couple hundred watts to get a horsepower, well, then you can tie a standard generator onto that motor and create 750 watts. So
closed loop, and then you got free power.
Close loop it, and then you've got 500 watts left over to do with what you want. Exactly correct.
Yeah.
And so, like we say, and there's all kinds. I can take you to labs all over the United States. I've got a network of inventors, and it's just among the network, it's just a common thing. We all do it, or we all have our different ways, but it's just a fact. It can be done. And I've seen it countless times numerous different ways. We've done it ourselves for years, and it's just a fact. Magnetism is a source of energy. And so when you really realize that, there's just lots of different ways to do it. And there's some incredible inventors out there. I mean, labs all over the country, and device upon device, and it all boils down to the same principle. Magnetism is a source of energy. And since the age of neodymium magnets, it's even better yet.
Yeah. I actually watched a video a while ago that I sort of discovered something, and the guy wouldn't reply to me because I wanted to ask him for permission to use that anomaly that I saw in his video. And he had a slow motion camera, and he took two magnets, and he wanted to create a spark with a neodymium magnet. I'd say that they're like 1 inch by 1 inch by 1 inch, which I heard in your video that was your first encountering of a magnet, of a neodymium magnet. But when he smashed them together, it did the spark, but he slow-moed it, and afterwards you saw a magnetic flux corona. Like you actually saw a visible corona come out of the magnet, and then it went away. And that will definitely be something that I'm trying to get a slow-motion camera to do that, so I can do that experiment. But what's your thought on that? Because if I'm going to ask anybody, it would be you. Why would it make an actual visible light?
Because
them together?
Because you've got some kinetic resonance going on in there, and so it's like quartz crystal will do the same thing. If you strike it with a vibration, cause it to vibrate, it'll actually create light and electricity. It'll vibrate at high frequency, and you can see the light effects going on inside the crystal. And so you have a neodymium, and all the magnets are very crystalline structures. So anytime you have a crystalline structure and you have a kinetic force applied to them, you will get light and heat and all kinds of things out of them.
So is this light like? Does it look like a small corona, or if you light a lighter and it barely has any fluid left, it just makes a little blue flame. It's not yellow, but it's just a little slight blue flame. Will these crystals do that?
You created a high voltage, high frequency field there, and it ionized the air. And what you're seeing is ionized nitrogen, basically, which has a blue-greenish look to it. And so you can do the same thing with a piece of quartz. And the thing about neodymium is what most people don't know is you have to be careful with it, because neodymium will actually catch on fire and burn like magnesium.
Really?
And absolutely. You can actually, put it on and put a little piece of it on an anvil and strike it with a hammer, it'll set itself on fire.
Now, don't experiment with this at home, kids.
Yeah, that's my recommendation. Be really careful, and anytime you experiment with stuff, be careful.
Or me, Marco said, or me. So, like, for all those that may not remember it from high school science, you can get these little magnesium strips, and it takes a few seconds to light them on fire, but they're almost impossible to get to put out unless you smother it completely.
Don't put water on it.
What's that?
Don't put water on it; it just burns faster.
Yeah. That's how I'm assuming, because the temperature is so hot of the burning flame that it's actually causing a thermal electrolysis, which then has a burning source.
Yep, absolutely. And neodymium will do exactly the same thing. You can you can get it to set it on fire, and when it starts to burn, there's no putting it out. So, and it's a real safe material. I mean, it takes, if you put a torch to it, you can get it to burn, or if you hit it too hard and crack it or smash it, it'll set it off too. So it's something to keep in mind. It is a flammable material under certain circumstances.
I never knew that at all, and that's pretty interesting.
Yeah, I didn't. When I got told about it, I didn't believe it till I saw it. The company here in Spokane, they built magnetic health devices, And so they made a lot of their own magnets, and we were visiting one day, and he says, "You got to be careful with these." Okay, I said, "No, I don't get that." He just set it on an anvil and hit it with a hammer, and man, it took right off, burned a pit right in the anvil. So
Wow.
that's what I said.
Now, this gets my scientific mind running. Would that have happened if he had it on like 2 pieces of aluminum, or was it the iron inducing something into the magnet that caused it?
I'm not exactly sure, but I know kinetic energy will set them into flame. So,
Yeah.
and but they're the most incredible magnet. I just love them, man. When neodymium came along, it's what made our motor possible.
Yeah.
And because it's just nothing can overpower neodymium, and it's even when it takes about 300 degrees Fahrenheit to 150 degrees or so Celsius even to get them to lose their magnetism, which is pretty dang hot. So they're tough. They really hold up, and I just love them. Best magnet ever,
So how strong are the magnets on your motor? Are they N52s?
If I have to remember here, I think they're about 2,000 gauze magnets. We actually got them out of, the whole idea was to have custom magnets built for it. But when we suddenly wound up poor and our budget was under $20,000 to build the thing, we wound up buying Edmund Scientific neodymium magnets, and we built arrays with them. They're pretty strong neodymiums, and that's one of the things our coupling between armature and stator isn't nearly as efficient as it could be, and that's another fix we got to do with our number 2 build when we do it. But because the strong magnets are so strong, there's a lot of stray flux and whatnot. But we used, I think there's 12 2,000 gauze magnets in each head of that motor. So,
okay.
And so, but it worked enough to prove the principle. And if we customize the magnet design, we'll even get a lot more torque out of it.
Okay.
Like I say, it's the very first one. It was built as a proof of concept prototype, and it proved the concept great. Now it's time to build number 2.
Yeah, well, you got your variables down, so now you can expand and know. When I sort of design something, I design it with what it could be and what it should be and what it won't be. I usually like to start with what it won't be, so that way the won't be's allow you to understand the nature of the beast. So.
Yeah, well, exactly. And see, when you're doing R&D research, you want to find the answers without going broke.
Yeah, but a lot of the answers aren't out there. They're not easily accessible, and I did a lot of research on hydrogen, and you have to go to physics to learn about hydrogen. So some of the questions that I had, which actually pertain to one of the hardest questions I had to find answered, was the thermal electrolysis. With what is the temperature water must reach in order to start breaking its bonds. So I eventually found it, and now I've obtained that knowledge. But a lot of knowledge isn't easy to find, and that's why we really want to try to turn this radio show into not just a source of knowledge when we're sitting here discussing things, but an actual source of knowledge for people to keep coming back to. So.
Oh, absolutely, and that's knowledge is power, and categorizing and sharing knowledge just becomes very synergetic, and my deal is to inspire. That's what made, I grew up in a family of inventors and tinkerers, and those, some people just have the knack for tools, and the more people I can inspire to go create their own little lab and go down and experiment and play. For one thing, for me, it's just great fun to be down in the lab blowing things up. You blow things up, you have failures, and then the other half of it is all of a sudden you make discoveries and you don't have it's really cool, but you don't even know how you did it. And then figuring figuring out what you did comes after the discovery, you know, and that's happened to us countless times. You know, you're looking for a result, and then all of a sudden you get another result, but it's really cool too. And then it's taking that empirical data and analyzing it and figuring out what's going on. And it's a brain challenge, and it's a, you know, and it makes you think and use your genius and innovate. And it's what made, the North American mindset is it's you know, we have two nations of just tinkerers and inventors that just really created the whole modern world, you know. And it's because we're free. We have access to resources, and no one's telling us that we can't do it, and no one's, you know, we don't have to ask permission, so let's do it, you know.
Exactly.
The more in the garage, the better.
Yep. You know, the biggest issue is that not all of the information is available for these people, and you know, a lot of people don't know how to build things. So that was actually the reason why I asked if you would be willing to do like a small version prototype, even of just something similar to what you got now, and you know, give people the materials they need to even just operate one or two coils, or maybe it won't work like that. I don't know, but.
You know, one of the, you know, that's why I really, you know, John Bedini and I were pretty good friends, and the guy is, he's an incredible guy, but that's why I really recommend a great place to start is the John Bedini Schoolgirl Motor. You know, it's a great place.
Oh, it is.
And it is.
Sorry, go ahead.
And the thing works, and it's fairly easy, and you got a little bit of everything. You got some basic electronics, and you learn how to solder and a little mechanical stuff, and you know, build a coil, and you can take that thing to the nth degree. You can keep expanding it out and adding coils and improve circuits, and you know, it's just a great place to start and wet your teeth, you know. And
I completely agree.
And with us, our stuff is a little more complicated electronically. I mean, it takes a bit of electronic skill to deal with our stuff. And I think in the near future, we're going to be creating some kits and building kits to build our switching technology and whatnot, and to where people can take it to the next level, you know. And we've been doing a little bit of stuff with John's motor, putting our touch to the electronics to it a little bit, making it a lot, kind of turning the Volkswagen into a Ferrari a little bit. And we've got some great results. So. I have one in the shop. We run at 24 volts, and you know, it spins fast enough where it'll fling the magnets off of it. So.
Are you guys epoxying them down, or?
Yeah, we epoxied them down, but you know, we were using a plastic wheel, and it didn't quite have the bond we thought the epoxy had. You know, so.
No, the plastic. It's did you try sanding the plastic first to create a stronger bond? Yeah.
We just put a plastic ring around it to lock the magnets down, so that problem's gone. But you know, we were just hitting some pretty high RPMs. I didn't have my RPM meter, but it was whipping. So we've been doing it at 24 volts and 36 volts, and adding more coils, and it really rocks good. So, you know, I've got a small group of people that have been helping do it, you know, and spreading the knowledge and helping them, you know, learn how to solder and, you know, basic electronics, and they've really come a long way. They can go build these things all day long by themselves now. So, and they do, you know. So a lot of them have solar systems and whatnot. You know, they went and installed solar systems and put 12-volt batteries in, and 24-volt systems and solar panels. And they've got their Bedini machine down in the basement right alongside the batteries, always throwing a charge in it. So, you know, and so people are doing it, you know, and so.
What one of the, I don't know if you knew, but Peter Lindemann was on the show, and we have a guy that's listening right now. I won't say any names, but he's he's sort of gotten away from the Bedini motor, but I'm sure that he hasn't ruled it out. But he sort of wanted to take the Bedini motor, and because it's such an efficient motor, he wanted to put the Bedini on a small generator and create some power. But he's sort of veering away from that right now. But he's got the generator and everything. Do you think that would have been possible to do exactly what you were saying with your motor, in regards to, you know, only consuming 250 watts on a 700 watt generator to then close loop it? Do you think that would have been, that is possible?
It's probably possible. I couldn't tell you for sure because I haven't done it, but I know it. You know, the Bedini, even though those magnets are spinning and you do have some torque and horsepower on the shaft, it's really designed to do. It's involved with the chemistry of the batteries and getting that flyback kick, which actually opens the ether door, you might say. But it's, you know, I guess it would just depend on, you just have to do it. I'm not exactly sure if you can get enough torque there to where you weren't dragging it down so slow, but it sounds possible to me. You know, I've thought about the very same thing, but just, you know, haven't explored it.
Have you ever thought of oscillating the generator to, say, charge a capacitor bank rather than putting the full load and slowing down the mechanical force?
Yeah, well, you can do that, and that's a great way to do that. Is you build up and you can actually build up a charge into a capacitor that doesn't drag it down too much, and then you can turn right around and take that capacitor charge and dump it into a battery or whatever you want to use, or drive a motor or whatever with it, and not actually put a whole lot of load on the drive wheel. You know, there's all kinds of ways to skin the cat, you know.
Yeah. No, that's why I brought it up. I wanted your opinion.
And that's why I encourage people to go out. Man, if you got an idea, try it out. You know?
Yeah. Wow. I'd have to quit my job and basically not sleep for the rest of my life to pursue all my ideas. So.
Oh, I know. There's just never enough time in the day to do it all. No,
there isn't. And, you know, a lot of the stuff that, you know, we're doing, it is extremely time consuming. I wanted to mention, I sort of forgot to mention it in the beginning. I had mentioned to people that we were sort of going to be calling out Fast Freddy for next week. We have to postpone that show. And he's Frederick Wells, the guy that apparently ran the 2000 Dodge truck on water, but most of the other water fuel researchers sort of have something else to say about it, including myself. But it's taking a lot of work to write down every single claim this guy made, and he's made a lot. And I could even actually mention a few of the things to you and actually see what you thought. I know that you said that you weren't, so yeah, by the way, we'll be postponing that at least for another 2 weeks. So we do have an opening for next week's show if someone knows an inventor. I know a few that I could fill in if we can't get someone else in the meantime. But now this Frederick Wells guy, he wrapped aluminum tape around his HHO tubes, turned the thing on, and he had electrolyte in the water. And then he turned it off, and he said, "Look, it's still running." It was producing hydrogen bubbles. Without me telling you anything, aluminum and electrolyte, sodium or potassium hydroxide, do you know what was happening there?
Yeah, he was eating up the aluminum, you know, chemical reaction, you know, just good old, I would say that, you know, not knowing what electrolyte he used, probably sodium hydroxide. And I can't remember. I have some chemistry experts I always refer to when I have these questions. But, you know, you drop aluminum is pretty reactive. So when you drop it into caustic substances, you're probably going to generate hydrogen, whether you're running electricity through it or not.
Yeah, the aluminum oxidizes, bonds with the oxygen, and then it releases hydrogen, and then you're left with H2O and aluminum oxide, and you have less hydrogen in your water.
Yep, that makes perfectly good sense to me.
So this guy, he was selling kits for $5,500 for a basic HHO kit with a tube cell, you know, a PWM. I don't even know if he was selling the microprocessor chip for the vehicle. And he went around saying, you know, here's my truck, buy my kit. And people were under the, you know, impression that they were going to be able to run their car on water. And then he was making claims like it was costing him $5,000 to build the kit, and he was only making $500. What do you think of that?
I think it's buyer beware, man. I mean,
and he had his own machine shop too.
You know, I'm not against people actually creating stuff and selling it. Just make sure your claims are real and practical, you know.
Exactly.
And there's a lot of people who actually believe what they're telling themselves. I see this all the time with electricity and experimenters. They go read the basic electronic book, they read their meters, and they say, well, all I got to do is multiply voltage times current, and that tells me the power, and they think that they're doing over unity. Well, wrong. I've watched too many people fool themselves by not having enough knowledge to get into it, but not enough knowledge to really do in-depth analysis. So it's really easy to fool yourself. And so that's why we're loath to make a claim until we've thoroughly researched and analyzed it, measured it and tested it in every direction we can think. We do multiple measurements, multiple testing, and we know how to measure power. You know, that's one of our days. And so before you make a claim, get an expert, somebody who can go in there and be willing to, and it breaks your heart when you think you've got it and then you find out you don't. But I'd rather have better the sour truth than a sweet lie.
Exactly. Yeah. Well, I think it was definitely a profitable, you know, venture. That it was sort of planned out. There was a big mysterious, you know, name. But we can get up. Sorry, what's that?
Yeah, I'm not willing to call somebody a con artist until I've met him and analyzed it. And he might have thoroughly believed what he was doing and could have been very wrong about his claims, but believed he was right. So,
well, he was saying he was running a truck on water, but prior to going public with it, he admitted to me that he was using a hydrogen tank, and then he went to town with it when I said, oh, you should be making, you know, about 55 liters a minute to do it at, and then you know, so he sort of used my words against me. That really pissed me off. So, you know.
I understand, you know, and
right. We can get off this topic. I just wanted to bring that up and see, you know, ask a few things of what you thought about it.
There you go. You know, until I always take it with a grain of salt till I've seen it for myself and I've analyzed the facts, and then I'll say. But I also know that most people are well-intentioned, but they fool themselves, and then they get on the soapbox and start telling things that aren't true, and then it always comes back to bite them, and then they set the movement back. And that's why one of my things is keep it to yourself till you know what you're talking about. You know, and
exactly.
That helps the movement out a whole lot when you do that.
Yeah, it does. It just that's one of the things that aggravate me the most, is because he's sort of making a bad name for all the other researchers that have spent years and years researching on HHO, and someone goes and buys one of these kits thinking that they're gonna, you know, that they're gonna not have a fuel bill anymore, which is possible. It is definitely possible, but you know, he would never validate his claims. And when he was supposed to go and I think he was supposed to meet someone through PSN or something to validate it, and then he made up this story that I think it's a made up story, but then he said that he had an attempt on his life. So he's never proved it to anybody, and so, but you know, it is what it is, and I have to overanalyze every single thing that he's done and said. So,
and well, you know, and the proof is in the pudding. If you make the claim, you better be able to prove it. It's like with us and our commercial products, we always get third-party validation. Everything we do, we go to a reputable laboratory. We hand the keys to the Porsche over to them and say, and we're not even allowed to touch the device while they're testing it. And then we get a third-party validated report that's detailed and scientific. And then nobody argues with us after that. You know, we took it to another lab. They tested it. They put it through the paces. And then it's their claim and not just our claim. And it's and if inventors start to work together, see, one of the problems with, you know, is, you know, divided and conquered, you know. We need to start.
I gave him open arms. I said, let me help you. Let me become a part of you. And then it sort of looks bad on me because I'm bitter about the guy that is taking people or has taken people's money. And now he's back again doing it. And now he's, you know, using a term called hydrogen plasma. He's saying the HHO is now hydrogen plasma.
Yeah, and and that's all, you know, maybe that's his theory and his belief, but once again, let's put some proof together, you know. It's like, that's where if you're the consumer out there or you're researching and studying this stuff, I take everything with a grain of salt, and everybody else should too, right? You read it, you know, that's why I read people's stuff. And, you know, I've spent a lot of stuff buying, you know, we did it last summer, or a couple summers ago. We bought a bunch of HHO stuff off the internet just to test it out and play with it and see if it really worked, you know. And there's some stuff out there that's great, and some of the people are making practical claims. This is, you know, depends on the motor size, and they explain all the factors, and other people are just pie in the sky, and, you know, they're selling junk and they're claiming that they've solved the world's energy problems, and it's garbage, you know. So once again, buyer beware.
Yeah, well, it's you know, it's not fair to the consumer because they just have so much hope for, you know, our future in energy. When some guy comes along and says, hey, I got it all solved, their first reaction is like, oh, awesome. Okay, how can I get involved? How can I support it? What can I do?
And that's where guys like us come along. They can do the analysis and say, hey, you know, you're wrong. Here's the real skinny on stuff, and the consumer deserves that information, you know. One guy makes a claim and the other guy says, oh, you're wrong and I can prove it, you know. And then the consumer actually has some kind of counterbalance to make up his mind about, you know. And there's just going to be a certain amount of this stuff as things move along, and it's been that way since the beginning of history, you know. Shysters and charlatans are about 10 or 15% of the population, and I just don't see any way around it. But, you know, a few people are going to get burnt, but over time, we should be able to work a lot of that out and make it go away, you know.
Yes, exactly. Now, I wanted to ask you, who, you know, you said Newman sort of inspired you to get started, but who are some of the other people that really inspired you?
Oh, I've been, from the time I was a kid, Benjamin Franklin, you know, I read all the classics, Faraday, Tesla, all of them. I just absorbed that stuff. And then in the early 80s, I really got into reading a lot of Bearden, and that's where I started reading Bedini and Bearden and all. And so many of them, I can't even remember their names. And anti-gravity is another thing I've really liked and studied a lot. You know, Brightfield Brown, all their writings. You know, I just loved it from day one, you know. Even a lot of the old stuff from the 1700s about perpetual motion. God, some of my family used to laugh at me about perpetual motion, but I could just never find enough of it, you know. And so all of it, you know. Like Benjamin Franklin, he's one of my serious heroes. You know, he was the original electrician, though, the guy who did something with electricity that was practical for the first time. And his insights is still, you know, we still use Franklin terminology. You know, just that innate curiosity. And then Bearden was a huge influence, you know, back in the 70s and 80s. And, you know, like I say, there's a bunch of them. I just can't pull their names right off the top of my head here for the moment. But, you know, it's just been a lifetime of it. And Tesla, absolutely. I mean, just like I say, as time went by, I just realized that Tesla was a prophet. He was not just an inventor and a genius, but a prophet too. You know, I mean, someone who was sent to change the world, you know, and
completely agree.
And it's just, and to me, this is going to be the true Tesla century. You know, he utterly transformed the last century, but by the same token, we got robbed of his promise. But this is a century where his promise is really going to happen. I mean, It's just, you know, there's so many people out there who have really revived his theory, have explored his theory. It's like Lindemann and Bedini and all those guys have just done a great job. Jim Murray is another guy. I mean, if you want to know about Tesla, he is the guy. I mean, he's another guy with a laboratory full of stuff based on Tesla. There's just lots of them out there. But once again, they're all poor. They all have a laboratory full of stuff. They won't back down from they'd rather be poor and keep it going than be rich and sold out. So it's an amazing. I know inventors across the country, and they're all poor and starving right now. And it's tragic one way, but I also know their time is coming too.
Yeah. Now, what do you you know, I'm sort of worried that if you know, a better system sort of isn't in place prior to the, you know, the sort of switch over to free energy. You know, my concern is that there's going to be some serious problems and issues that arise because, you know, yes, we are humans and we adapt, but to adapt that quickly to a quick switchover, which is, I believe that we're going to get to a point, and we're getting close to that climax. And as soon as that climax happens, the world is going to be like, okay, we're ready, let's do it. And when that does happen, do you see sort of the negative aspects if we don't put things in place, you know, prepare for it?
Well, I kind of look at it this way, you know, vested interest. The whole drawback to humanity right now in the world and why things haven't changed, you can boil it down to one term: vested interest. You know, status quo keepers. To me, you know, they say, oh my God, if we change the world, oh my God, you know, and there's a system in place that provides huge amounts of power, control, and wealth for a handful of people. You know, and they're the problem, because free energy devices will generate vast amounts of job. It'll generate decentralized wealth rather than centralized wealth. And that's where the rub lies. You know, so many people don't understand the petrodollar, right? If you think the US government or North America wants oil consumption to go down, you're crazy, because the petrodollar, the more oil that gets consumed, the more the dollar's worth, the more centralized wealth you have. And that's why it's status quo, because it's a centralized, monopolized system. So, well, it's breaking the monopoly, and it's going to be a war and a battle. You know, it's just how it is. And the more people that start providing their own energy individually, small companies, nothing scares big companies like small companies. Big businesses, death of small business. And that's why they skew the system to their favor. But it's the war has started, and when energy becomes decentralized and energy becomes clean and utterly cheap, it will generate more wealth for the middle classes around the world. It will build the middle class. It will take the load and burden off the planet, and it'll be a very positive thing. But people better get used to the fact that it's going to be a type of a war, and we all have to take part in it. It's, you know, and you know, big elephants are scared of little mice. You know, it's how it works. And if you got enough mice, you take over. And so that's it. It's about breaking the central monopoly control. And it just has to be done. It's happening now. And you can see it squirming.
Yeah. So I guess we'll try to take in a few more calls for the last little section here. If you want to call in and you are on the website, please but press mute first. Go to the Skype, press mute as soon as you click on it, and put a number beside your name. And if anybody that's already in the chat would like to ask a question, Alien has a question. Go ahead, Alien.
Yeah, you worked a lot with radiant energy and stuff, you were saying, or I know Matt was saying and stuff. Have you worked at all with laser technology?
Little bits. I'm not a real laser expert, and it's
have you made your, like, you can make simple lasers. Have you ever tried making a simple laser with, like, different methods of coils and stuff? Go on.
Yeah, actually, years ago I helped a guy build a CO2 laser, and it worked really well. It punched nice holes through the door.
Right. Well, yeah, that's totally, usable in the industrial field for punching precise holes into things, right?
Yeah, and it was pretty good. We had the CO2 tanks hooked up to it, and the flash tubes, and we just built it out of a set of plans, and I was quite amazed at how well it worked.
And that I think that's basically the arc type welder type laser, right?
Yeah, it was a red laser, and you can start a fire with it really good, and and then I played with lots of small, LED laser type stuff, and so there's
also a lot of use for high powered magnets, for higher powered magnets too, like for your magnets that operate on, your lasers that operate on ultraviolet scales and such, different wavelengths of light. Super magnets are really an integral part of that. I know that.
Oh, absolutely. There's just so much. The uses for magnetics is just infinite. And it just gets more so every day. And and I've never really done a whole lot of laser stuff, but I've done lots of other things with magnetic research. That's what I love the most, And
as you know, lasers can also be low frequency emitting diode lasers, like your LEDs, can be used for communication devices and such, and you're communicating at the speed of light. Yeah.
Absolutely, and they can also be used. I think they can be used integrally in transmutation of materials. A lot of different things, chemistry.
Yeah, they use lasers in chemistry too, right? Mm-hmm.
And we do a lot of things. We're doing a lot of water research. It's not exactly HHO research, but we apply electromagnetics to water, and we've done a bunch of incredible things. And we have learned we break down chemical chains and all kinds of things, and lasers are really good for that. You can take really bound molecules and for little bits of energy break them down and then reconstruct them into new materials, and just endless things you can do with it. And I wish I had more people working for me in bigger laboratories, because we'd be doing it all if we could do it. But it's only in a day. And but I love playing. I love lasers. They're great fun.
What area are you in, Paul?
As geographically?
Yeah.
We're in Spokane, Washington State.
Okay. Well, you got a few guys that are listening in that are near you.
Yeah. This is kind of a hotbed of inventors. We got the Spokane. We're right next to Idaho, and Lindemann, Bedini. They live right in Coeur d'Alene, across the state line here. So we're all pretty close. There's quite a network of people here in the Northwest who are really doing some amazing things. And so I just, like I say, my job, keeping flyback energy going, eats up most of my time. So I don't have as much time as I'd like to deal with the experimenter community and just do pure R&D now that we're into commercialized products and, you know, making a company
Well,
go.
Paul, if you didn't live on the other side of the continent, I would be over there building and experimenting things just to do it for free, just so I could do it. So I almost would guarantee you that there's someone else here listening that would probably offer the same thing to be able to have access to a shop like yours. And if they were to contact me, would you be willing for me to forward them to you?
Oh, yeah. Always into expanding the network, you know. You'd just be amazed at how many geniuses are out there in the underground, you know. How many of them they work a tough job, and some of them work low-wage jobs, and they take every penny they got. They go there in their garage every night till midnight, you know, then dragging out at 6 a.m. to go to work, and you know.
Stop talking about me.
I know the deal, you know. I did it for many, many years, you know, and they've just got labs full of great stuff, great theory. I mean, there's just an army of geniuses out there. But like I said before, you know, divided and conquered, and bringing them together and being able to work a team and pool resources and share ideas and create. And the other missing piece is to find people in the business community and the money world who are willing to be a part of the new changeover, you know. And I find that's the real missing piece, is to get money people out of the old paradigm, you know.
It is. It definitely is.
Because after spending 13 years of raising dollars and finding stockholders and doing business deals, I find it's just that world's pretty backwards. It's the part that needs to catch up.
Yeah, it is. And we got to actually wrap up the show, Paul. I thank you so much for being a part of the show. You shared so much valuable knowledge, and I'm almost certain that you've inspired a few people to go get some shotgun pellets and build themselves a coil. You know, thank you so much for being a part of the show.
Oh, no problem. Anytime. It's been great, and I'm glad to help anybody out there who's part.
I'm impatient with stupidity.
All right, everyone. So thank you so much for being a part of Inventing a Free World. You can check us out on darkcityradio.com or inventingafreeworld.com. I'm your host, Matt McMahon, and you just heard Paul Babcock. Thank you very much. Have a good day and night and future.
My people have learned to live without it. I'm afraid my people haven't. I'm very sorry.
Well, I can respect your opinion. Sadly, I'm afraid you'll have to die.
Do not try to escape.
What do you want? What are you doing? Let me see you as you really are.
Dark City Radio.
Is there anything we can do?
Nothing. It's practically under our feet.
Filled in because of the fact that it was so, you know, their technology's outdated now. You know, they didn't have microprocessors and you know, even to, you know, high switching and things like that. So
absolutely, it's like Nikola Tesla and Faraday and these guys. You know, basically they had lumps of metal and wood, and you know, that's all, and a little brass and some screws, and that's all they had to work with. You know, and they literally explored electricity in depth with virtually nothing. I mean, their mind power just boggles me to this day. You know, their intuitive powers, you know, and how they could create all this stuff, like Tesla's creation with what he had to work with, what he created. I mean, what, you know, I don't look
visionary.
At Tesla, not just a visionary, but a prophet. You know.
Yeah, well, that I think that's sort of one and the same, is it not?
Yeah, and just, you know, and to me, we got robbed of about 100 years of progress by the powers to be. I mean, we're literally back in the day when Heaviside and and all these guys were developing the laws of induction and whatnot. They pretty much warped a lot of the real math that was coming out of it to just create a standardized system. You know, Maxwell, Heaviside, not that they weren't genuine guys, but so much of what was possible was pounded into a simple mold that basically said, you know, that stuck to, you know, tried to fit electricity into the law of thermodynamics, and it put it in a box. And the box led to the system we have today. Well, now, you know, and Tesla said, well, you've robbed this century of what I can do, but the next century is mine. And I think that's where we're at right now, is all this theory is coming out of the box that was hidden from us.
Yep.
And that knowledge is spreading rapidly.
Yeah, many people can feel the change happening, like not only feel it physically, but, you know, you just look at all the inventors that are really putting themselves out there that are, you know, not so, they just want to use the ideas that come to their head as methods for other people to learn. And, you know, could you get into a little bit more about your motor? I'd really like people to share. And actually, before we do that, the videos that I saw, I definitely suggest anybody to go and purchase these videos. They're more than worth watching them. So if you want to know how free energy works, Paul's going to explain it to you, and he's going to give you math, especially if you are a physics buff and you think all this stuff is a bunch of hooey. You know, I was absolutely blown away by watching these videos. So you guys got to go and see what he has to offer in regards to knowledge. So where can people find that video?
A&P Publishing, you know, Aaron and Peter Lindemann's video publishing company, which the name of it escapes me right. A&P Publishing, I believe, is the name of it. But you can find it on energeticforum.com. And, you know, we all worked in the big electrical industries. You know, we started out as just basic technicians and taught ourselves engineering. And pretty soon we were top troubleshooters for big corporations around the world. And we were the guys that dealt with the electrical physics. And all of us, my business partner, my brother and I, we just had this, you know, we just knew that there was something missing in the theory, because we'd see these energy phenomena when we're playing with big DC power systems and whatnot. And of course, we're all Tesla fans and read all the stuff. And we just were trying to pin it down. What was going on? Where was the theory? You know? I mean, it was just incredible, some of the phenomenon we'd see that nobody could explain, you know, and of course we're dealing with big companies and whatnot, and they just sweep it under the rug, but we'd find the solutions to problems, and we all made really good livings at it. And then how the real inspiration started was when I was in Alaska, and I was having kind of a rough year, and I'd got hurt in an accident, and I was out of work, and so I was living in this little cabin in the woods, and just getting by, and arm in a sling and a cast, and it's about 50 below zero, and chopping wood with one arm, and all I had was a little AM radio, and we had this local radio announcer who announced that his guest that night was going to be Joseph Newman, and so
the Newman motor guy,
and that was in like 1988. So
okay.
I said, well, you know, being an electron chaser, and I said, man, this sounds great. You know, I just got to hear what this guy has to say. And so he, you know, he totally captured my, you know, he was saying, I got what he was talking about, while the guests, while the audience was giving him a hard time, calling him a quack and a moron, because they couldn't believe that, you know, over unity was a possibility. So I scraped in. He just said, well, buy my book and read the book and then criticize me. So I went and I scraped up the $50 and bought his book. And when it got to my door, I opened the pages, and there was this this is one of those epiphany moments. There was a simple statement he made, and it was just absolute brilliance. And from that moment on, I jumped down the rabbit hole and never looked back.
What was that statement, Paul?
It was that the amount of energy you expend to make a magnetic field has absolutely, the amount of energy you expend to create a magnetic field has nothing to do with the amount of magnetism you make. In other words, what he was saying is by controlling the mass in a circuit, you can create a whole bunch of magnetic flux for a little bit of energy, or you can spend a lot of energy to make a little bit of magnetic flux. That there was absolutely no direct relationship between those two. And it was like getting hit upside the head with a frying pan. The implications for that. You know, being a serious electronics guy, I understood that, wow, if I can make a very large magnetic field because of Faraday's law, and I don't expend very much energy to make that field, I should actually be able to get more energy back out of the magnetic field than I used to make it. And so then I started working, and it was just from that moment on, that epiphany was, like I say, that's when I jumped down the rabbit hole and I've never looked back. And that began a lifetime, 30 years of serious research and development, and to develop the electronic systems it took to exploit his theory. So I studied his theory very thoroughly, and I studied everybody. And then after the studying got done, this is okay, now it's time to go to the lab. And so that's what I've been doing for over 20 years, developing the control systems in a way and a whole new level of electromagnetic control and manipulation. And we've done some amazing things with it. So that motor you see is basically a Newman-inspired system. And so that all that came out of that one epiphany, that one moment.
That's usually what happens to all of us that sort of make us want to pursue an alternative. It just took one person's technology to just get you wanting to learn more about it and wanting to explore that. And then when you do that, you tend to expand into other things like, as you did with Tesla and, all these other amazing inventors that have never really had a chance to have the future that they saw come to life. And it's very unfortunate.
And that's how it works through history, is we always stand on somebody else's shoulder, and then somebody will stand on our shoulder as society progresses. And so, to have all these great inventors and great minds, I mean, they be inspired and point out very basic things led to my own inspirations, And so one of the things the first thing we started to do was, how do we, Tesla, Newman, how do we relate it to the known laws of physics we already know? Ohm's, Kirchhoff, Faraday, all these basic electrical laws of physics that we live by and have created a civilization by. I says, this has to relate. So what we did was we basically proved that OU is a total fact, and our known laws of physics, Ohm's law, Faraday's law especially, say it. It's just staring you right in the face. And so that's what my videos that you watched are about. That's what when I do lectures, that's what I speak about, is it's already there. We already know how to do it. It's, if you know how to run the simple algebraic proofs, it's just a fact that electromagnetism, or magnetism specifically, is an energy form unto itself.
Yes. I wanted to mention something in regards to all these people that sort of made physics what it is today. They were also inventors, and they found a way to apply their understanding so other people could understand it in, mathematical terms. Now, it doesn't mean that they had the opportunity to test everything. They only had, especially due to the fact that most of the physics books were written over 100 years ago, that their understanding of even what we can presently do today is nothing in comparison. And there are laws that are within physics, but there are definitely a lot of holes that need to be filled.
Side pops into your head, and then spirit juice takes over, and you just can't let it go, and you pursue it till you figure it out.
Yeah, I call it a beam of light. as we've discussed, my theory is that that most humans are sort of interconnected, and we can connect through sort of paths of light, because most people know that human bodies are magnetic, and light is a type of magnetism, as I believe from what I've looked into. You may want to correct me on that. And I would more than.
I call it the biological internet.
Okay, yeah, and as we've both discussed, that we sort of we both have the ability and belief that we can connect with other minds around the world on same or similar ideas, or random ideas for that matter.
It's absolutely true, and it's also a timeless thing. Every generation has the same thing. There's just people who are here to bring this information to a generation, and that's their job. That's why they're here, and they have that special talent, and I don't really focus on it a whole lot. I just let it work in its natural form, and it works great for me.
Yeah, that's. So did you notice that it happened more when you actually started teaching yourself about different technologies, or was it has it always just been the same?
It comes when it's supposed to. It's like I'll spend sometimes a year or two in the lab, just trying to work out ideas and whatnot, and then all of a sudden a question will drop into my mind, and a whole new offshoot takes place, or I'll be reading somebody else's work and I'll see a simple sentence or a statement, and then all of a sudden, pow, it just flows into your mind, flows into your being. You start to vibrate. As Tesla described it, to paraphrase, the inventor's rush, is better than sex.
The orgasmic epiphany.
Exactly. And man, once you get it, you're hooked for life. There's just nothing quite like it.
Yeah, it's a drug that you keep trying to keep finding it. You actually really nailed it there by saying that. Sorry, I'm just trying to cover for my work right now, for my second job. You had said that when you look at another device or you read something and then boom, you get it. No, it's the question. I often find that if I look at something, I go, the thing that triggers mine most is what if? What if it was like this? What if it was like that? And then my brain takes over and sees all these visualizations and starts going nuts. So how about we get to your motor? That's quite an interesting piece of equipment. Could you try to verbally explain it in a visual sense?
Oh yeah, absolutely. It's maybe a little bit of the pre-work on the physics and how we came across the physics is, my brother and I we've been chasing electrons together since we were kids, and I wound up, I spent many years in Alaska, and
Hey everyone, welcome to Inventing a Free World with your host Matt McMahon. Today's show is with an inventor named Paul Babcock, and we'll be discussing secrets of magnets, magnetic secrets. I'm happy that we could share this with you. So I just wanted to say a big thanks to all the people that are involved in the show, that help out, and Kiki for doing the art, Marco for doing the websites, and the rest of the team. If you guys need any services, everybody's always looking for work, so you guys can check out our team on inventingafreeworld.com. We are presently on Dark City Radio right now, and you guys got to check out the other shows that they have on here. They're doing some amazing stuff. You guys got to listen up and hear what these people have to say. Natural cures, talking about environmental issues. There's a ton of stuff that is really open to the open source mind. So I'd like to welcome Paul Babcock. Hi, Paul. How are you doing, buddy?
Oh, doing great. Pleasure to be here.
Oh, it's a pleasure to have you. I'm very excited to have this show. So Before we get started, I like to ask the other inventors, about the gifts that some of us share, and how does your gift of inventing work, and how far back do you remember it happening, and what happens? What are the triggers? Is it a device? Is it just a random thought? Is it just an image that enters your mind? How does your gift work? Besides the knowledge part.
Yeah, I guess it goes back to birth, the desire to just, I had this thing about electricity from as early as I can remember, 4, 5, 6 years old. And it turned into a hobby that turned into a career that led to really studying electrical physics very deeply. And then I just all of a sudden realized that how they were telling me the world worked and how electrical physics worked wasn't exactly how I was coming across it in the real world, and it just started me on a path of discovery, and I grew up in a family of inventors. My uncle invented farm machinery and just everybody, tools, electricity, so it was a great environment to grow up in, and it's just been a life's inspiration.
Awesome. That's and what about the I've asked a previous guest to the show. First of all, do you have visions? Do you see devices in your head? Does it work like that, or is it just?
Oh, absolutely. It's like I try to describe it to people, and a lot of inventors out there have said the same thing. Is they literally have a world in their mind, a laboratory in their mind, and when I go into the laboratory of my mind, I do experimenting, and it just sometimes it's with dreams, sometimes you'll just be sitting there in a chair doing something innocuous, and it's like getting hit by a brick,